So thanks everybody for showing up. I thought I would give an introduction to what glass plates are, since most of you have been transcribing for PHaEDRA or star notes, and you've been looking at all these numbers, and you know that if they start with a letter sequence, they represent a glass plate. But what is a glass plate, right? I know this is not exactly the most common thing that people see every day nowadays. So usually when I tell people that we have about 550,000 glass plate photographs, people will think of something sort of like what's on the background of my screen right now, right? You have colors, swirling gases and dust and little pinpricks of light. But that is a very modern photograph. What we're talking about is much older. We're talking black and white photography on glass. So you might think of something like this one, right? You have black background, white dots, because, I mean, when you look at the sky, that is what you see. However, all of our glass photographs are in the negative. So this one here is in our collection, but this is actually a positive made from a negative in our collection. So they look more like, let's see. Oh, there we go. Like more like this one, right? It takes a little bit of getting used to because you're not used to seeing things in the reverse. So right here we have a white background with black dots. The black dots are your stars. And right here, in the bottom, we have a sort of swirly thing. That is our friend Andromeda. So this plate is from 1945. It's just one of the many types of plates that we have. I have a few here that I'll show you. Here's another one. This one is from 1925. It looks a little different from the one I just showed you a second ago, and that's just because the size of the plate is different. It had a different lens on it. There are all different kinds of images in our collection. Here's another one. This one does look a little more familiar with these swirling gases in the middle. This one's from 1945. That is in the Milky Way. And this is the last one I'll show you really quick. This one is from 1910. It is one of our more famous plates because it is Halley's Comet. And this, I believe, was taken in Peru. So we were taking these images not just in Cambridge, where they are currently now housed. We were taking them in Peru, in South Africa, Jamaica, pretty much anywhere where we had some telescopes set up for the Harvard Observatory to specifically be taking these glass plate photographs. So I showed you a couple glass plates, so you know what they look like now, but how were these made, right? Not many people are used to taking this kind of image. Some of our earliest photographs we have are what we call wet plates. Before even wet plate photography in the 1850s, there were daguerreotypes, which I know Wolbach does have a small collection of. Mostly they would take images of the moon, but for astrophotography, they were interested in looking at the stars, and daguerreotypes weren't very good at taking those kinds of images. So when wet plate photography came around, astronomers were very interested in trying using this technology to capture images of stars. And I just want to take a second to tell you how difficult this type of work was. To take a wet plate photograph, you not only had to cut your glass and then get it ready and make it extremely clean, then you had to steam it and put an albumin solution on top of it. It's called subbing, basically preps your plate to then hold another chemical solution that you had to make called collodion that you would pour onto your piece of glass. And if you see on the far left, I was lucky enough last year to take a workshop on how this is done. It was really fascinating, if just to explain to me how difficult this process actually is. So on the far left, she is actually pouring on some of that collodion liquid. And it has to be done very evenly so that you can get a nice image. Once it's dry, you then have to dunk it in a silver nitrate solution, which is what's going on in the center photograph. And that will put all these tiny little silver particles onto your photograph. And those are actually what are going to change color when it's exposed to light. And in this case, that would not just be from a camera, it would be through your telescope. So once your photograph is being exposed to light, where the stars are going through the telescope and landing on your little glass plate and darkening it where the light is hitting. When you're done with that, you have to then do another chemical process to basically process your plate. So it was a long process to get one of these photographs done. This wet plate photography was active roughly from the mid 1850s until the mid 1880s. While astronomers did use it, it wasn't great for astrophotography. And the main reason isn't even just because it was really complicated and easy to mess up. It's because it wasn't terribly sensitive for fainter stars. So you could get images of very bright stars, but these plates were only sensitive to light while they were wet, hence wet plate photography. Once they were dry, they couldn't get any of the fainter light that was coming through. Luckily, for the sake of at least our collection, dry plate photography came around the mid 1880s, which really helped this project take off. The reason dry plates were better, and you can probably guess from the name, they were dry instead of having to use wet chemicals. So they were actually, well, first off, you could buy them in bulk, so you didn't have to bother making all of your chemicals beforehand. You can see on the far left, that is a photograph of one of our glass plate manufacturers, Hammer Dry Plate. They were also using glass plates from Eastman, later Kodak, Kramer's. There were a bunch of different vendors who would make these, not just for astrophotography, but for photography in general in the late 1800s. So you would buy these pieces of glass that already had a dry emulsion coated on them. And then what you would do is you would take it out in the dark. In our case, it would be your telescope dome at night, and you'd put it under your telescope. And that was the most complicated part in the beginning. You didn't have to mix all of your chemicals. Afterwards, you still did have to have a dark room so you could develop your photographs, which you can see in this slide on the right. We have an image of what used to be the Harvard Observatory's old dark room, which is kind of it no longer exists, unfortunately. And I have no idea where in the building it used to exist. I did try to do a little bit of investigating. You can see in the bottom photograph, that's what our observatory used to look like. We don't have nearly as many domes there anymore, but that is how dry plate came around, and that's what most of our collection is. I would say wet plates, we only have about 2,000. The majority of the rest of our collection are all dry plates because it was just so much easier. And it was also better because you could expose your plate to starlight much, much longer. So you could get really faint stars showing up on your glass that you couldn't even see with your eye, because your eye doesn't collect light over time like a glass plate would. So this was really valuable technology for astronomy at the time. And just to give you a visual of how exactly your telescope would operate like a camera, we have a couple different setups for our astrophotography telescopes. On the bottom right, you can see I think his name is Henry Sawyer. He is actually feeding a glass plate into the bottom of the telescope, and these cloths would be used to block light. So almost like if you've seen old images of photographers where they would throw the black cloth over the back to keep the image where the glass plate was contained, that is essentially what's happening. But instead of a camera, you have your telescope. And I should say these telescopes were made special for taking astrophotography. They were not the same telescopes you would use to view with your eye. So you can see where you would have your lens or for your eyepiece to look through a telescope. Instead, you have holders for glass plates. And I'll also mention the bottom right corner, this photograph of Mr. Sawyer. For the longest time, I thought what was in his mouth was a cigar. And in fact, I think it's actually a flashlight because he had to do this always in the dark. So if you're doing transcribing for PHaEDRA, you are probably familiar with some of the types of work that were going on with these glass plates, right? And you know that the women computers were the women who were using them for this research that you're transcribing. Just to give you a little example of what this type of work looked like, in this photograph from 1891, on the left, we have Mabel Stevens, and those notebooks she's working on might look a little familiar to you. She's doing some calculations based off of glass plates. And on the right, you have Wilhelmina Fleming. And she is actually looking at a glass plate. It's hard to see in this photograph, but she has a magnifying glass up. And this little holder that this plate is in is made of wood, and the bottom is a mirror, because this would have been before we had electricity in the observatory. So she would actually be using sunlight to look at her glass plate. So those window shades would have been open if she was really doing her work instead of posing for a photograph. But you can get the idea from this image. You are probably familiar with some of the notes from these glass plates. I just want to show you a couple different types of work. So depending upon what your assignment was, if you were one of these women computers or astronomers who were using plates, you would be doing different things. You would be looking at different areas of the sky. You would be looking at different types of plates, looking for different types of objects. This one is just one of my favorites, so I figured I would show it to you. It's plate B2312. And this is a discovery plate for the Horsehead Nebula, which was found by Wilhelmina Fleming first in 1888. And the nebula in question is not the most obvious one on the plate, right? When you look at the whole plate, you see this spot in the middle, and that's actually Orion. That is not what we're looking for. What we're looking for is this really faint squiggly line. I've outlined it in red so you can see where on the plate it is. And if you sort of squint and turn your head, you can see that it does kind of look like a horse head. But when you show modern day images of the Horsehead Nebula, it definitely looks a lot more like a horse head than the technology of the time, these glass plates. It's really interesting to think most people, if you're interested in astronomy, you know of the Horsehead Nebula. It's one of those common images that we see. But it's just nice to think that in 1888, this was the first time people had the technology to be able to see it, even very faintly on these glass plates. One other type of work I figured I would show you. I know we don't have unlimited time, so I can't show you everything, but one of my favorite types of work that was going on in these glass plates was galaxy counting, because literally that is what they were doing. So these plates, this type of work is common in the 1930s to the 1940s. So if you were a woman working at the Harvard Observatory in this time, you would be going inch by inch over these plates and trying to decide if one of these tiny black dots is a star versus a galaxy very far away. And the way you would do that would be, if it's a sharp point, it's probably a star. If it is fuzzy in any way, it might be a galaxy. So in this case, on this particular plate, someone named Muriel Mussells, she worked at the observatory in the 1930s and 40s with her sister, actually. Sylvia Mussells was there too. And they were looking for anything that looked even a little bit fuzzy on a plate. And if it was fuzzy, they would mark it and put a number next to it, because they were literally counting how many they could find in this area. On this plate, so MC 27415, in the middle, we have Andromeda again, but all of these little tick marks with numbers that are surrounding it, most of them are in blue or purple. Those are all suspected galaxies. And you can see on the bottom of this slide, I put a photograph of the paper jacket. So every plate comes in its own little sleeve. And a lot of times the people who would use these glass plates would write down what they were working on. And they would put their little notes on these jackets. And in this case, Muriel Mussells, if you look through her notes, you can see how many new nebulae did she find? 458 on this one plate, which is pretty remarkable considering they had only just realized that galaxies were a thing that existed. Of course, nowadays we know we can't just look around and count how many galaxies there are. There are billions. There are way too many for that. But this was the beginning when they were trying to find out how many there are, where are they dispersed in the sky. There were so many questions that we didn't yet know about galaxies. So it's just fascinating to me to know that this is where it all started. This is where we started to figure all of that out on pieces of glass. One thing that I'm sure most of you, if you're transcribing for PHaEDRA, know is that these notebooks and also these glass plates are extremely important for recognizing scientific contributions that women made to astronomy. So just to name just three very briefly, we have Henrietta Leavitt, which I do believe many of her notebooks were transcribed already through PHaEDRA. She discovered the Leavitt law, which was a yardstick for measuring distances in space. That top plate on this slide here, that has the small Magellanic Cloud on it with a bunch of notes. Those little letters that are kind of down at the bottom, those are most likely her handwriting for when she was looking for Cepheid variables in this region back in the early 1900s. Other people who were very important, Cecilia Payne-Gaposchkin and Annie Jump Cannon, they both used a different type of photograph that we have. They're called stellar spectra. And that on the bottom is an example. Those are two stars. Those two smudgy lines are two separate stars. And what you would do to get this image is you would put a prism into your telescope so that your starlight would get chopped up and you'd get rainbow patterns. But this is black and white photography, so we're not looking at rainbows here, but that's okay because they didn't really need the color for the type of work that they were looking at or that they were doing. What they really wanted were these vertical lines that are running through those little smudges. And those were different patterns, and they knew that those must mean something, but it took decades of studying them before they figured out that those spectra, those lines, those absorption lines, can tell you how hot a star is, the chemical composition of a star, all kinds of important things. So it's just interesting to me to think that we now know that stars are big, hot, gassy things in the sky, but they didn't know that necessarily when they were looking at these back in the late 1800s and early 1900s. It took several people going through and looking for different patterns to try and figure out what they mean before we learned exactly what a star even is. So that's what the plates look like. But what about nowadays, right? We still have this collection. It still exists. We still work with them every single day, including now in 2020. We are still going in every single day and working on these plates. The environment looks slightly different on the right. This is just an image. It was behind my desk. I literally just turned around and took a snapshot with my phone. Our cabinets are now made of green metal, whereas you can see in 1895, they were made of wood. We also have a lot more of them than we had in 1895. We have 3 floors of storage, and the building we're in was made special just to hold all of the weight of that glass. 3 floors of storage of glass is a lot of weight, so it's reinforced, and the cabinets are actually connected between the levels. Supposedly, they are not firmly connected to the walls in case there was an earthquake, so everything would shake separately. I don't know how true that is, but that is the lore, and I will take it. The building we're in right now was made in 1936. That was the last extension that was made specifically for holding glass plates. Our team also looks a little different, right? So in 1891, it was almost all women, except for Edward Pickering, who was the director at the time. You can see him on the far left. In 2018, we're a bit more diverse, right? And I will point out that we do not work with telescopes anymore. We are not collecting glass plates anymore. That stopped in the 1990s, but we did take our photograph on the roof with the domes just because we thought it looked cool. Josh Grinley is the head of our current project that we have going on there, and he is on the far left on our 2018 photograph as well. So the project we have going on right now is called DASCH. That stands for Digital Access to a Sky Century at Harvard. Basically, every day we go in there and we're scanning glass plates to put them online so that anyone can access them. This is not a kind of project that's only available to Harvard. It is anyone can go online and look at our digitized glass plate photographs. We are currently, at least as of last week, our most recent count was 410,000 scanned plates. Our first scan was roughly 2007. It may have been late 2006. We are really hoping we'll be done by this summer. We've had a few bumps in the road throughout this digitization journey, not only with the pandemic and being offline for 3 months, but in 2016, we had a massive flood that took us offline for almost a year. So we're a little behind the schedule, but we're thinking we'll be done by next summer, fingers crossed. I also will note it, I will just at least note that even though we have 550,000 glass plates in our collection, not every single one of those will be digitized. And that is because the DASCH project is mostly interested in direct image plates of stars. They don't want spectra. They want anything that's like one little dot equals a star, and that is because it's being used for time domain astronomy, where astronomers want to be able to look back in time 100 years to see how those tiny little dots have changed, right? What stars have fluctuated and why. And it's really kind of fascinating, the kind of work that astronomers are using this information for. They are looking for exoplanets, they're looking for black holes, all kinds of things can be learned by looking at these changes in light over 100 years. That said, all of our other plates, like this lovely moon photograph here, will be digitized eventually. They're just not part of the DASCH project. I'm hoping we'll get to them next because they are really very beautiful. I mentioned today we are still working, still digitizing, and this is just a quick little, explanation of the different types of work that we have to do to digitize a plate, right? It's not as simple as taking it off the shelf, photographing it, and putting it back. The very first step was transcribing all of our logbooks, which thankfully the Smithsonian Transcription Center did for us a couple of years ago. That was so helpful because we had to have all of the information for our glass plates ready before we could scan them. So each plate has a ton of metadata attached to it now, including a unique number. It tells us which telescope was used to take that photograph, where the telescope was pointed in the sky, the date, any users of the plate. There's so much information for each image that had to be transcribed first. Thankfully, when that was finished, that meant the rest of the work could be done. So we then take it off the shelf, we barcode it so all of our computers know which plate we're looking at. I personally have to look at every single image because there's other information that we have to make sure that we put into the database, including if there were any historic users, like we saw that plate earlier that Muriel Mussells had used, or Wilhelmina Fleming. I want to put that into the database. If there is a multiple exposure, so which means if there are many dots per star, we want to note that too. There are all kinds of things that we look for that we want to make sure to record before we process the plate, which then means it goes to be photographed. We have Sammy in the middle in this slide. She is photographing our glass plates. They also have to be cleaned because if there's dust or fingerprints on them, we have to make sure that that isn't going to mess up the astronomical data from scanning. Eve on the far right is at our scanner. It was made special just for this project, and she's cleaning some dust off. She has a little brush. And then Helen on the left is actually mending some of our photographs because with this much glass, things get broken. So we have archival safe methods for mending our glass so we can still keep using it going forward. So I'm going to stop there. I just want to say thank you to everybody who is transcribing this information because it is essential for us understanding the work that these important women did throughout history of astronomy, right? And I just want to point out that it's not just about giving them credit for the work that they did, but it's also about showing that there is a precedent for women to be interested in these different fields of science, right? Women are not only now interested in studying science and physics and math, they always have been. They just didn't necessarily have the same opportunities and their work wasn't necessarily documented. So that's where I will stop. And thank you for all the transcription work you've been doing. Should I pass it over to
yeah,
Sam?
well, thanks so much, Lindsay. Maybe we could start with if there are any questions for Lindsay before moving on to questions about Zooniverse or other things. So if anyone has any questions for Lindsay, just please unmute yourself and go ahead.
Are the photographic plates available for downloads as JPEGs or as FITS files?
Both.
Okay.
Depending upon what you want to do. So if you're an astronomer and you want to look at a particular, let's say you want to look at an object and you want to see all of the photographs we have of that object, you can download all of its files and put it into whatever program you're using. We also have the JPEGs if you just want to look at one image at a time. It just depends what you want.
Are the FITS files available for the public?
Yep, they are all on the website. So it's the DASCH website, DASCH.
Okay. Thank you.
You're welcome.
Thank you.
Anyone else? I also saw, I will say, we do have a couple members of the DASCH team here too as well. And I should say thank you for all the help that you've been doing on this project.
So,
other questions?
I'll ask one.
Hi.
Even though I know about the project a lot, I don't know a lot about the progress. And I'm curious, about how far you are on the large plates, the A series, the large A series plates as opposed to small A series plates? Are those done now, or are they?
Oh,
Or-
Jessica, that is a great question. We actually just started them about 3 weeks ago. I've started looking through every single one. We haven't started scanning them, but we're reviewing them, photographing them. As of today, we just started sort of cleaning them and getting them ready to be scanned. I'm hoping, if we're lucky, maybe we'll start scanning them by January. That's the hope.
For those of you who don't know about the A series plates, they're the largest plates. They're 14 by 17.
Yep.
They're meant to compete with the Arc-to-Ciel survey because Pickering thought that he could do a better job than they could. It was done by a large collaboration of observatories all over the Earth. Each had a latitude band, and they tended to not, or effectively a declination band, and they tended to not get done at the same time. And it took years and years. And he thought we could do this in just a few years. So he had this telescope built and did it in the north and did it in the south. And they're really neat plates because they're as big as the Palomar Sky Survey plates that are used for the digitized sky survey, but there are 10 times as many.
Yeah, and they are very difficult to handle because they are so big, but they do tend to have some of the most interesting images too.
Yeah, and the scanner was built to take them as a maximum. So it can do 2 of the regular 8x10s at a time.
Mm-hmm. Yeah. Any other questions or comments?
Just out of interest, so you're saying, you know, these plates are of interest to astronomers currently because it gives you historical data. Have there been any kind of stunning findings as a result, or?
Any stunning findings? I don't necessarily know all of the work that people are doing with them because it is open to the public, so anybody can use it. If I'm not mistaken, there might be a bib file on I might be speaking too soon. I think there is a list of anytime someone cites the DASCH project. I think that is available maybe through ADS. I might be mistaken. But I know that they have discovered things. Like I think a couple of years ago, someone was looking through old records. I want to say it was like the Korean royal astronomer noted like a big light in the sky back in the 1400s. And then someone went back through our place to see if there were any remnants of this, supernova, and they were still there. So there are lots of very interesting things. I know people are looking for exoplanets. The PI of this project is interested in black holes. So those are 2 things that these plates are definitely used for now. But there's a ton of things people are doing. I just don't necessarily know every single project. Yeah.
My favorite project is Su Min Tang's project looking for really, really long period stars. And that was when they were trying to develop how well you could do relative photometry across different plate series. And so she found for her PhD thesis, she found some 100-year period stars where they had a whole period of the star the variability of brightness. And I was just impressed by that because you couldn't do that any other way. To have a complete scale like this and see that it really is periodic. But it was really hard because that was sort of a proof of concept that you could actually even do it. Because I think Wilhelmina Fleming got sidetracked. Who got sidetracked? Oh, Henrietta got sidetracked into trying to do relative photometry across different kinds of plates. For North Polar sequences, and it was really hard because the problem is the plates change color over time because the emulsion's not always constant over time or on different plates, and so you actually have to have a reference catalog of stars to look for variability that has the stars that aren't changing in it. And the good enough multicolor catalogs didn't become available until this century. So when we started to work on this project in 2002, we couldn't do what we wanted to do yet because the catalogs weren't quite there. So it's really pretty exciting that the stuff that has existed for 140 years, we couldn't really use it to the full capability until the last 10.
Yeah, these plates are, they're very valuable if you want to have the opportunity to look back in time. It was really forward thinking of Pickering and the team to start taking these photographs back in the 1800s, because no one was thinking, yeah, we'll want 100 years worth of star data to see what was going on, right? They just anticipated that this might be useful someday. And sure, yeah, it sure has been. So people can still use it, and it's pretty exciting. Other questions or comments? No. Well, there are an awful lot of glass plates, and they are being digitized now. So if anybody's interested in particular subjects, whether they're objects in the sky or particular historical subjects, I'm always available and happy to help people find plates for anything that they might be interested in.